Welcome to the Chemistry Learning Channel. I'm very excited to share my passion of chemistry with you, and I hope you'll enjoy the video. In this video, I'll be talking about density and going over density calculations. Density is very important to understand how the physical universe works and is a key physical property of many fluids and solids. It helps us understand how material interacts with one another. Density. Density is the amount of mass per volume. It describes how much stuff is packed into a fixed space. The units are grams per centimeters cubed or kilograms per meter cubed for solids, and the common measure is grams per milliliter for liquids. Density describes how heavy something is for its size. So if something is very heavy for its size, like a heavy metal object, we describe it as being more dense. And density is described by the equation rho equals mass over volume. Rho is the common variable, Greek variable for density. And just to give you a reference, water is 1 gram per centimeter cubed, which is equal to 1 gram per milliliter. And when an object has a greater density, it usually sinks. And if an object is less dense than water, it floats like oil. In this slide, I will be talking about how density relates to the states of matter. As you can see, solid is the most dense, followed by liquid, followed by gas. This is because if we took this cube shape and we took a sample from a liquid and from a gas, we could see that this cube is more packed versus if we took the same shape over here, it would be less packed. And then if we took the same shape in the gas, it would be even less packed. And this is because the atoms in solids are more rigid, and then they're less rigid in liquids, and then they're free to move in gases. Next, I will be going over an example. I will be discussing how to calculate the density of a solid. So the problem is a 20-gram cube takes up 5 centimeters cubed of volume. What is its density? So we'll start with the density equation. Rho equals mass over volume. And then we can plug in the variables that are given. So 20 grams is the mass, and then 5 centimeters cubed is the volume. And so if we compute that, we'll get density equals 4 grams per centimeter cubed. In this slide, I will be discussing how to calculate the density of a liquid. This problem is a little bit more involved than the previous one, so let's start. A bottle contains 16 fluid ounces, which is equal to 473 centimeters cubed of a liquid. If the mass of a full bottle is 3.3 times 10 to the 3 grams, and the mass of an empty bottle is 1.7 times 10 to the 3 grams, what is the density of the liquid? So first, we will be starting with this equation. Mass of the full bottle is equal to mass of the liquid plus the mass of an empty bottle. So let's fill in what is given first. We're given the mass of the full bottle, which we'll plug in here, and then we're given the mass of an empty bottle, which we'll plug in here. This gives us the mass of the liquid, which is equal to 1.6 times 10 to the 3 grams when we rearrange the equation. Then we will use this to substitute our variables into the density equation, which is, we'll start with rho is equal to mass over volume, and the mass of the liquid we found out to be 1.6 times 10 to the 3 grams, and then the volume of the liquid is given in the equation as 473 centimeters cubed. So this gives us a density of 3.38 grams per centimeters cubed. It is important to make sure we keep up with the units, and density is, in this equation, this is for the liquid. So we need to make sure that the mass is for the liquid and the volume is also for the liquid. I will be going over finding mass when density and volume are known. The problem says gold has a density of 19.3 grams per centimeter cubed. What is the mass in grams of gold with a volume of 2 centimeters cubed? First, we will be starting off with our density equation, which is rho equals mass divided by volume. Then, because we're solving for mass, we will be rearranging the equation, which comes out to mass equals rho times volume. Then we will substitute our knowns. So 2 is the known volume and 19.3 is the known density, which gives us 38.6 grams of gold. Example, I will be talking about finding volume when mass and density are known. The problem is the density of aluminum is 8,000 kilograms per meter cubed. Find the volume of a 100 kilogram block of aluminum. So first, similar to the last problem, we will start with density equals mass divided by volume. And then we will rearrange the formula to solve for volume, which is equal to mass divided by rho density. And then we will plug in our known variables to solve for volume. So we have 100 kilograms, which is the mass, and then 8,000, which is the density. And this comes out to 0.0125 meter cubed. In this slide, I will be talking about how to calculate the density of a spherical solid. This problem is a little bit different, and we will be calculating the volume of the bowling ball first. So we have a bowling ball here, and we are given a radius of 8 centimeters. From this, we will use the equation V equals 4/3 pi r cubed. And here we will plug in the radius of 8 centimeters, and when we compute, we get 2,144.6 centimeters cubed. And then from this, since we know the volume and we have the mass, we can find density. We will plug in, we'll start with the rho equals mass over volume, and then we'll directly plug in the 6 kilograms and then the volume, which we calculated. In this equation, so we're using the density of a solid equals the mass of the solid divided by the volume of the solid. So it's important that we have the states of matter the same. So this equals 0.0028 kilograms per centimeters cubed, which is also equal to 2.8 grams per centimeters cubed. Thank you for watching this video. If you liked it, subscribe, like, and share.